Right, this is ZS6YI. Let's just hope it's all working. We say a very good morning, good afternoon and good evening to everyone on frequency. And welcome to the worldwide net of the Digital Amateur Television Group. And we certainly hope that the streaming is going to work out okay today. We're trying something new. And it looks like it's working, just quickly listening to it. Firstly, we wish to thank the Qatar satellite company for allowing us a bit of space on their satellite. Without their help, of course, this would not be possible. We also wish to thank the AMSAT DL and also the AMSAT UK group, as well as the British Amateur Radio Club, for the valued assistance and help that we've got on their various sites. And you will see that we did have a link to their web pages. Listeners, today we have Saro over U2OBR, who sends his salutations. The poor guy had a nasty accident on his motorbike a couple of weeks ago. Him and his son were driving on the highway at about 70 kilometers an hour, and the highway is not very well lit, and a dog came from the side, which he didn't see, and actually ran across the road and in between Saro's wheels, and he went over the dog with his rear wheel, and of course they fell. Their son was with him. Pleasant. I saw some photographs. Beautiful motorbike, completely wrecked. So, Saro, we wish you well. I know you're watching, and I certainly hope that you and your son have a speedy recovery. Thank goodness it wasn't worse than that. Right, today on the net, I just want to go and have a look at the, let me just see, at the roster. We have Leon, ZS1 Mike, that will be coming up with a nice slideshow on the space program he's been discussing with us over the last few weeks. We have Ed, Papa Yankee 2 Radio Note, South America, going to LD. It's going to be very interesting, Ed. And then we have Benno in Holland, Papa Alpha 3 Foxtrot Bravo X-Ray. And he's also streaming on Twitch. So you can go to his stream, twitch.tv/Papa Alpha 3 Foxtrot Bravo X-Ray. And then hello Martin, G4FKK. Yeah, Martin and I were knocking heads, not together, but together, trying to get the streaming to work, but eventually I got it to go, and so far, touch wood, it's working, Martin. And then hello to Mike, G0 Mike Juliet Whiskey. That's on that roster. Let's just see on the wideband side. Hello Hans, Papa Alpha 3 Echo Tango Kilo. Welcome to you. I see you just watching. Henry, I hope you're going to come up, ZS6 Mike Charlie. Henry's, I'm going to put you down, Henry, in case you can come up. You'll come up after Mike, if that's okay. I'm just writing this down. Henry, ZS6 Mike Charlie. Hopefully Henry will come up. He put through a good signal yesterday. And that's all I see on all the nets. So, right, let's pass it to ZS1 Mike, who will give us this presentation on space once again. So, Leon, if you can, ZS1 Mike, to please take the microphone and video from Zulu Sierra 6 Yankee India.
Okay, it's locked. Right, ZS6 Yankee India and the whole group, ZS1 Mike, saying a very good morning, good afternoon and good evening to whoever might be watching and listening. Yeah, Gary, so by the way, This is one of the boards that I made earlier when you phoned me. Oh, come on, focus camera, there it's coming. So yeah, they both came out fine. I must just trim it now, drill it and clean it and put the clear lacquer on, and then I can assemble it. Okay, right. Yes, I want to talk a little bit about auto tracking. Now, following things in flight, you can either manually point an antenna to them or at them, or you can have a computer program running with the correct data if it's something in space that's got a fixed orbital pattern, and we call that slaving. But when you get to very fast moving things like close by, like low flying aircraft releasing bombs, aircraft firing missiles and things, you need proper auto tracking, what we call auto tracking. In other words, once you've locked onto the thing with your antenna onto the RF signal, it's not going to leave it, and you don't need any external inputs. You just need the RF signal and it will follow it at a very, very high speed. Missiles traveling at Mach 2, no problem. So how do we do it? There are two basic ways that I know of, maybe there are more, to auto track. The system that we use, which we found works very well, is called Conscan. There is another system which is more complex but no moving parts, but very finicky, and that is called monopulse. Our Doppler systems that we had used monopulse, but yeah, we don't use Doppler. Since the invention of GPS, you don't need Doppler to get the speed of a thing. If it's got GPS on board, it's no problem. Okay, so I've prepared a little slideshow which was a more detailed recording of how we deploy our antenna, just the antenna, never mind the rest of the stuff now, because in there I can tell you a little bit more about how the auto tracking works. Now, I don't know where to start, because it's the auto tracking is in three parts, or it revolves around three things: the antenna itself, actually the feed, it's a very special feed, it's a very special antenna controller, and also it needs a proper telemetry receiver. Because although the modulation we used in 90% of the cases is FM, or phase shift modulation, PSK, or something like that, or even BPSK, tracking a proper telemetry receiver which is tracking capable also has an AM detector in it. So when you're receiving your FM carrier, there's no amplitude variation on it, or very little anyway, not of any significance. But if you can put AM on it, that's a different story. So let's start this thing, and I'll tell you. Okay, well, hang on. First I can show you. There's now the thing will go into its demo mode. The other camera. That is the back end of my old tracking telemetry receiver. Now you'll see there, that's the antenna input. Now all missile tracking and space tracking, so it's all done in S band, 2.2 to 2.3 gigahertz, so very close to where we are operating now. And it's got lots of outputs. This is only half of them that I'm showing, but there you see the video output. That's the unfiltered video output. You also have a filtered output on the other side. You have AM video output, which is the actual AM output. What is AM? It's basically AGC, which is decoupled DC wise. So any variation in signal strength is actually AM. And so it carries on. Then there's another thing here, pre-D record out. In telemetry, this is a dual conversion receiver. Normally the standard is 160 meg first IF and 20 meg second IF, and that's where you do all your demodulations. But then it's got a third down converter to 800 kcs. You can select it depending on your data rate, so that you can actually have a low enough IF to record on a high-speed analog tape recorder. The benefit of that is after the emission, you can play back that thing through various filters, maybe a little narrower, maybe it's a slightly different slope on the demodulator, especially for deep space work where the signals are very, very weak and you have to squeeze the last 0.1 of a dB out of the signal to noise ratio. So that's what pre-D recording is used for. Anyway, so the big thing is your receiver must have an AM output, and when you go for auto track, you have to set your AGC time constant very low, very slow, or else it'll just strip off the AM. If you put a 1 millisecond AGC time constant, which these things can very easily do, you won't have any AM. So we normally run at 100 milliseconds AGC time constant, which is slow enough not to strip the AM off the signal. Where does the AM come from? Because they're transmitting FM from the missile or from the satellite. Okay, let's start the video. Just kill that camera and we start the video. Well, it's just a slideshow. Right, this was in New Zealand for ATV, the automatic transfer vehicle. This was ATV2 when we set it up. Okay, first we put up our gantry. It all comes in aluminium boxes. There is the pedestal of the antenna on its little cart. It's very heavy, so you pull it out and roll it to under the gantry, hook it with a block and tackle. There's the feed arm still strapped on top of the pedestal. You obviously will remove that, and then hook it. And there we've already put it up. The block and tackle is removed and it's standing on its 3 feet. Looks like a lunar orbiter. There's just another view of the pedestal. Now inside the pedestal are the servo amplifiers for elevation and azimuth, the power supplies, the motors and the gearboxes to move the whole thing around. There Herman is putting back the pedestal trolley in its case. So now we start the assembly of the dish. This is in New Zealand. It was like 5 degrees centigrade. There's all the ribs packed next to on the left hand side of the pedestal. You can see them. Herman is just posing for the picture. And just now we'll start assembling this lot so that we can put up the dish. There we've got all the ribs on. I'm tightening the last couple of bolts for the ribs. Yeah, and the light's low. But it's also difficult because I'm taking into the skylight. Anyway, so there we are. It's all done. Now the next step is to put the dish itself, the mesh, the reflector in position. Okay, we're tilting it down so that we can reach. It's got power on it by now, and we've got a manual hand to move it around. That's just another view from the back, 3/4 view from the back of the thing. There's the heatsink that I say we always point north. Okay, there's half of the dish. That's 4 segments being fitted. They just clip in and they've got latches that just latches them onto the arms. So that's 4, and there's the other 4 on top also inserted now. So there's the dish complete. Now it still needs the feed arms, the feed and the stub antenna. The stub goes right in the middle, right against the dish. That is where we feed the signal generator in for doing what we call close loop tests, just to check the system out. Okay, there the feed arms are in with the feed ring, that ring here on the tips of the thing, and the feed just bolts onto that. The stub is still not in. Just another view. There my colleague Herman is carrying the feed. Now please note there's a thick end and a thin end on the feed. That's very important. There is fitted, and the thick end is pointing away from the dish. That is the acquisition aid antenna, which we don't really use anymore. But just take a note of it. The thin end is the actual feed, which is pointing into the dish like any normal feed. And that is a rotating conical scan feed. Now I'll show you a picture of that just now. There the antenna is complete. The stub is in the middle there. Right at the dish you can see the little white thing there, the white dot. So we radiate directly from there into the main feed with a signal generator for test purposes and data streaming and things like that, or just for calibrating the stuff. So there it is, and there I'm pointing towards the feed. Again, I say the thick end is not used for auto, well, it can be used for auto tracking. Now, this was in Ghana, and there we had a feed problem. Those are 4 cross dipoles on the thick end. That's the acquisition aid antenna. And it's actually standing on the rotating feed now on the radome. And you can see the LNA there. This is the hybrid for commutating those 4 cross dipoles to make them auto track as well. We're not going to go into that because it's of no significance here. There's the LNA. There are 2 because we have simultaneous left hand and right hand circular polarization coming from the feed. There is the feed. And I was very fortunate that when I was at the work the other day, we had to take it down because there was a problem in it. Now you can see it's got a single cross dipole in the center, right in the middle, and it's a carbon fiber horn which can rotate. The motor's got a hollow shaft. Oh, I hope I'm not talking too loud. The motor's got a hollow shaft. There's a hybrid. On J1 goes the vertical dipole, and on J2 goes the horizontal dipole, and J3 gives out left-hand circular, and J4 gives out right-hand circular. It's a dual 90-degree hybrid. It's just a strip line thing, which gives you 90-degree shift, which makes, from a vertical and horizontal combination, it makes circular polarization. That's an old one I removed years ago, and I just replaced it with a new one. So, why do we have a rotating feed? We'll get to that just now. Let me just show you that. And there we're rotating it just by hand. The thing is upside down. On VLC, it's the right way up, but when I put it here, it's upside down. So I don't know why. But anyway, we just give it another spin.
Sure. Okay,
we haven't got power connected to it. You can see the cross dipole in the center, and that's, you see the feed is offset, so it actually wobbles your lobe. Right, that's the end of the video. Okay, now for the discussion. Right. So what's happening is when you are perfectly on target, say you're looking at the sun, which gives out enough RF, we can auto track the sun. You're pointing at the sun, and your actual beam is rotating very, very slightly. It's if you look, the center of this little wiggle is about 0.2 dBs down from the peak of the main lobe. So what's happening when you're perfectly on target? You're not getting any AM because you're just circling the target. But when you're off by just the slightest amount, you will have more signal in the one direction and less signal in the other direction. Now, what I forgot to mention is on this same motor shaft that's rotating that horn, on the back side of it is an aluminium disc. Half of it is painted black, the other is shiny aluminium. And there are 2 90 degrees offset opto pickups. It's reflective opto pickups. So that gives you 4 quadrants. A top, a bottom, a left, and a right. So the feed knows exactly where it is. So say you're looking below the sun, slightly below. When the beam tilts down, you get less RF, and when the beam is coming at the top, you get more RF. And you sense that it's at the top quadrant that you've got the more RF. This is now demodulated as AM, and it resolves that and converts it to a DC signal. If you remember, it's a pity I haven't got a static picture of the antenna controller now, but from previous videos you'll probably remember on the antenna control there was those 2 LED bar graphs. They normally, the little LEDs is just one in the center. The left-hand one is elevation, the right-hand one is azimuth. So when you're perfectly on target and the thing is auto-tracking, those LEDs will just stay in the middle. But if for some or other reason you stop the thing and the target moves away, say it moves up, you will see that the elevation one, the bar graph will light up more and more and more to the right as the error increases, because it sees, no, the RF is in that direction, it's not in the middle anymore. That demodulated signal is fed into the elevation servo amplifier, and it just zeroes it. It always just tries to, like any AFC or anything, it just tries to zero that and keep that thing in the middle. And the same for the azimuth. So the whole magic is in the Conscan and the AM demodulation, which is fed back to the servo amplifiers. So that in a nutshell is what Conscan auto tracking is. When we are very close, like say for instance we're close to the runway and there's an aircraft about to take off, then you select the acquisition aid, those four cups with each a crossed dipole in it. Top one, bottom one, left one, right one. And again it gives you simultaneous left-hand circular and right-hand circular. Why circular? On missiles, they allow you to have anything sticking out there. The airframe guys are very full of nonsense. The thing's got to be smooth. So they only allow you to fit a wraparound antenna, which is like a piece of PC board with etched little dipoles and things on it. Those things are normally linear polarized, but you never know how the missile is going to go. You know, is it going to be vertical? Is it going to... So the best is to receive circular. Then it can be in any position. You won't have any change in the signal level. You lose 3 dBs. The loss between linear and circular is 3 dB. So you must, in your link budget, you have to allow for that. But these antennas work so well. I mean, they've got very high gain. We acquire a satellite, a low orbit satellite at 3,000 kilometers, and it's only a 5-watt transmitter that they have on board with a very stupid little antenna as well. No big gain dishes or anything, because it's got to be omnidirectional. So yes, another interesting. Okay, but I was at the acquisition antenna. This thing, because it's not pointing into the dish, it doesn't get the gain of the dish, so it's got an enormously wide lobe. It's about 90 degrees, the width, so it's 45 degrees off axis either side. So this, in anything in that lobe you will pick up, obviously with much less gain. You lose about 35 dBs of gain, but you will, and it will auto track it, not very accurately, but it'll keep it, it'll follow it. And this is driven by the also by the signal strength of the received signal, and it'll automatically switch over to the main lobe once the signal drops a little bit, and then you get to the main to the other feed that looks into the dish, and then you've got proper high precision auto tracking. When they bought the antennas, they got these very interesting slide ruly things. Remember, this is like about 40 years ago. I've got it set now. If I can just get my note, maybe it's better if I put my finger from the top. If you look at this one, it says beam width, gain and efficiency, and you set the antenna diameter either in feet or in meters. That's the top one. So I've got it set for my 2.4 meter dish that I'm transmitting on now at 2.4 gigs, and that gives me a gain. There's your feed efficiency, which the best that a feed can be is 50%, and there you can see I'm at 32.5 dBs gain, 32.5 dBs gain that I get from my dish now. So you don't need a lot of watts to really hit the satellite. So this thing is full of all sorts of interesting things. Your nulls, your beam width, the beam width at the 3 dB point, there it is. It's about 3.5 dBs 3.5 degrees wide, my beam, on the 2.4 meter dish at 2.4 gigs. So yeah, very, very handy little tool, this slide rule thing. It's got all sorts of things. It's got goeters at the back as well. More information and all sorts of things, power conversions, and anyway. Okay, so I hope this mic, if you need to know more, you can ask. You said you'd like to know how we do it. By the way, those cups, there's nothing rotating there. So what they have there in that, when I showed that picture with all the plumbing and the stuff inside the feed, there's a lot of PC board stuff with pin diodes. So they use the same commutation signals from those optocouplers, and they hit the pin diodes for up, down, left and right. So they simulate Conscan. It's not multi whatever the other type is, I've forgotten now. The other type of auto tracking. Monopulse. It's not monopulse. Monopulse is a totally different thing, but it's very, very phase sensitive. It doesn't work very nicely, very low on the horizon, and for rapid moving things, it's not so good. So Conscan really works well. It's very simple. The RF part of it is very, very straightforward. Only two cables, or actually, if you're only interested in left-hand circular or only right-hand circular, you only need one cable coming from the feed carrying the RF. If you're running monopulse, you've got left-hand, right-hand, some signal, different signal. It's a whole lot of RF cables, and they all need their own LNAs, filters, and all that. And it's a very finicky system. Our 10-meter antenna at work is a monopulse thing, and it's a dual band. It's S band and KU band, not KU band, X band, S band and X band, Cassegrain feed, but it's all monopulse, and it's an animal. Anyway, so that is it from ZS1 Mike. I'll give it to Ed. Ed, I hope the signal was strong enough. I'm still D3 with myself. I hope you could also receive me. Papa Yellow 2, Romeo November for the group from ZS1 Mike.
Thanks, Leon. Thanks. Good morning for our friends in Americas. Good evening to Africa, Europe, and no, should I say good afternoon to Africa and Europe, and good evening to our friends in Asia. Thank you, Leon, for another great presentation. Really great. Copy 100%. Good signal, good audio, fantastic images. I admire your dedication in documenting all your work when doing those remote tracking stations and stuff like that. So that's beautiful. And the tracking system you just presented is like a dream system for the moonbouncers, I believe. Making EME would be so great to have this type of precise tracking system that is able to even measure the coming signals and adapt to it. Fantastic, really, really nice. I'm sorry for my low. I'm using my lower resolution camera to show myself, because I'm using the high resolution to show what I'm supposed. What I will try to show you guys today I didn't pre-record it, so it's gonna be live, so not sure if everything is going to be okay. But that's what I was playing this past week, testing some LDMOS and some MOSFETs. I just wanna try to show the very simple procedure. Most of you maybe are already aware, but maybe others not. So it's good to do this procedure, mainly if you buy those new LDMOS or MOSFETs from different sources, and before you install it, maybe it's a good idea to make this quick test. So that's why I'm gonna try to show you. Well, the first one is with the ohmmeter. Maybe this is the most known procedure, testing with the ohmmeter. So you have here the gate and the source, which is also ground. This should be open, and it's not, so it means the guy here is not good. And if you measure also the resistance between source and the drain, you should see a very high resistance, which is not the case. So this guy here is bad. It's really bad. So let's take a look on this one. Yeah, that one. Yeah, it gives me a high resistance. It's not open, but it gives me a high resistance between gate and source. Should be a high resistance also between source and drain, which is 3.3 meg. So that should be okay. Let's see this one. Yeah, this is even a higher resistance. Yeah, 3 meg. It seems okay. Yeah, those guys also already measure, and they are okay. This one is no resistance, is short, so that guy is bad. We don't need to deal with that. Another interesting procedure is, this type of case, although it seems ceramic, but it seems opaque, right? But actually they are translucid. And those guys, not only those guys, but most of the LDMOS, MOSFETs, they are, when this has this white case, they are photosensible. So you can just, turn on a light and measure some voltage between the gate and the drain. So I'm gonna show you. Don't remember what it is. No, it's here. Okay, here you can see it's about 35 millivolts. In this one, you can see here it's 25 millivolts. This one here very low, 7 millivolts. Doesn't sound good. And this one here about 19 millivolts. So to choose, like to match, I would choose those two guys to make a match, because it seems they have very close gain. Yeah, as you can see, if I hide the light, I will turn them upside down. So you're gonna see I can measure no longer a very low voltage because they are not receiving light directly. You see, only 4 millivolts. If I turn them back to the light, you're gonna see the voltage increasing. Yep. So those guys would be my choose to make a match, and the others are not so good, as you can see. Yeah, only 3 millivolts, not so good. Actually, I think, yeah, even well, that's a little crazy. But anyways, that's I would like to show you guys. It can be, this test can be done in a single MOSFET, like that guy here. That guy is XRF 286, XRF 286. That's 2 gigahertz, 60 watts. Or you can do in those double type of LDMOS. It's the same procedure. Or okay, yeah. I hope you guys could could see. No preparation here to make this test, so I believe you guys could see. Other than that, I'm gonna send back to our friend Benno. Thanks, Benno, for streaming the net. Also, Gary, I'm following your streaming is perfect. Congratulations. I see that you did lots of progress on that, so maybe now it's gonna be your turn to to give me some tips on how better streaming. But I saw some control screens. It seems that you're using ports down or something. That's I guess that you're using there, Gary. So Benno, back to you. Papa Alpha 3 Fox Bravo X-ray, Papa Yankee 2 Romeo November.
Okay guys, greetings to the south, the east, the west and the north. I always say, Saro, I hope you're feeling well and looking forward to see you back on the air, because I missed your famous face. You were there the first part of the bigger part of last year, and then suddenly you're pretty gone. At least you're watching, I believe, and I understand, so as soon as you're getting well, switch on the transmitter again. I want to see your face back on the air. Hi. Leon, thank you for the nice presentation. I was wondering how this works. It's kind of impractical if I would turn some moonbound antennas array this way. To get the AM amplitude onto it, but I got the idea, and it's a nice way. I suddenly realized how it should work and how it worked the minute you talked about a concentric carbon fiber feed around it. Okay. Ed, also something new for me. I didn't know they were photosensitive. I knew the other thing to measure the shortage or whatever. Something what I done multiple times already. But photosensitive part was completely new for me. And apparently you have a good one with a very bad gain, I believe. Well, nice stuff. Learned a lot already, so that's a great net today. As you see, it's quite sunny outside here. The weather perfect. And last week I did a lot of different things. The main thing I did is I wanted to work a local repeater, which is about 80 kilometers from here, which has a DVB-S input and I wanted to, and I can see it on the stream on internet. No, I cannot see it on the stream. On the control page, I can see if my signal was coming on, and that one was using the PID 100, 101, 102, which is kind of different than the one we are using 265, 266, 257, which are kind of typical for us. So I ended up playing with the latest version of Everest, the 303, the 3 March version, and I have still installed it, and I have 0 nil packets, but still a great signal, I believe, and completely my video is quite low, so I'm a little bit astonished, and I have no clue where I should go after that to get rid of the F0 packets, because that's my problem at the moment. It's way too high, and it's eating up my nil packets. But again, I see my signal is stable, and I'll leave it for that, because I wanted to work on this local repeater. But the older version of the Pluto were not able to produce the 101 and 102 PIDs. So if someone knows a little bit on that, I want to learn a little bit about that in the near future. What other things I did is follow Tom with his Arduino project on the Raspberry, tracking satellites. Managed to get the Raspberry part working, and last week I managed to get the Arduinos working as well. So I can simulate what he's doing, and I can do the same here, which is marvelous. Something I want to work on somewhere in the springtime, and I'm just gathering information, and I think this is the right path for me at the moment, following that. But that's satellite tracking according to the Kepler knowledge, so that's no way of tracking live, but more than predicted feed tracks on the Kepler part. So that works for most of the satellite, at least, and at least for my my dish, which has not a 3 degrees opening corner, but well, it's a 1.8 meter dish, so that will be a bitch to turn with homebrew and homemade stuff, and I'm thinking about driving that dish around. Okay, another thing I was working a lot this week is controlling my my analog repeater part, which is still behind me. I have, as you know, I am one of the workers on the local DATV repeater, ATV repeater. It was original an analog repeater, and I converted that to completely digital, and obviously that made a lot of improvement, but gave also a lot of problems. And the original task was to make it fully analog to analog, digital to digital, and every mix what is needed in between, so you can go analog in and digital out, and digital in and analog out, and all those guys need to be combined, and that's the part what I'm working at the moment, trying to control the old stuff, really old stuff, obsolete electronics, which is over 20 years old, and then needs to convert it to a I2C for controlling, and that makes a pain in the ass, as I am not a programmer, but I'm trying, and every now and then I get a few steps in the right way, and then thrown back a day or two. But I will manage, and I will make a nice presentation if the minute Leon stops his nice presentations, because I can never exceed that. Okay, well, leaving that, passing on to my friend Martin. Martin, take the frequency Golf 4 Fox Kilo PA3 Fox Bravo X-ray in the net.
Yep, okay, Benno. PA3 FBX. G4 FKK returning. Let's get a camera going. Yeah, very good. And well, I like your linguistical version of what we'd call a technical challenge, calling it a pain in the ass. Excellent. I shall remember that, Benno. Superb. And a very good morning, afternoon, evening to everyone. Especially Saro. Saro, hope you are watching today, and that you're well on the road to recovery. It's amazing how fragile the human body can be sometimes, isn't it? But also, hopefully, amazing how quickly it can repair itself. Usually, so good luck with that. And I hope your son's okay as well. I wonder what happened to the dog. Probably not good for the dog either, I suspect. Leon, I liked your PCB you showed right at the start there. I think you have told me before how you prepare those. You'll notice, by the way, the sun is very bright here as well, same as in the Netherlands. So it's quite cold outside, though. I don't know what the temperature is with you, Benno, but it's flipping cold outside, especially when the sun dips behind a cloud now and again. And all I can say on your presentation, Leon, was wow. That's every day's a school day. That's two things I'd never heard of before, which is the Conscan and the mono pulse tracking. I've never even wondered how it's been done before. So thank you for illuminating my brain there. Also interesting that your 2.4 meter dish has 55 dB of gain. Well, I'll have to borrow that slide rule device, and I've got a 1.1 meter dish here, which is a bit small, really, isn't it? But yeah, very interesting and fascinating. With some of the gadgets you've probably got in the shack there, I wonder if Tom could produce something for an Arduino to do stuff like that. That'd be great. Ed, I like the cartoon. A good cartoon. That's the best way of limiting the line loss, isn't it? It's put your house as high as possible. And well done on the live demo there. That worked very well. And same as Benno, I didn't realise that LD MOSFETs were photovoltaic in that way. So again, it's been a busy school day today, hasn't it? I wonder if the one that was showing less volts, I'm wondering whether the translucency of the white ceramic-looking tops are consistent, whether there's a speck. So maybe that one was a bit thicker. I suppose the proof of the pudding is putting it in a square kit, I suppose. Anyway, that was very interesting as well. And Benno, your activities with the repeater and and Tom's project, that's very encouraging, because I'd quite like to do a similar thing here. I have got a azimuth and elevation rotator, which the elevation rotator hasn't been used for many years, but it's sort of tempting. I guess interfacing the hardware is a bit of electronics. Talking of electronics, I'm afraid I've failed yet again to do anything radio related. I was just going to quickly show you, if I can bring out the unsteady cam. Where is that? There we go. Hopefully I've got some audio. This is I'm very pleased with this one. This is the movement from a 1926 watch, an Elgin, as the Americans call it. I think I'd call it Elgin, but there you go. That was a complete non-runner, but then it probably hadn't been looked at since about 1936 by the look of it. Anyway, it's come out really nice in the wash, and it's working well and keeping accurate time. Not that you can tell because it's upside down on a movement holder. There's another little watch here, and this was £5 on eBay, but I don't know whether that'll focus. But that's a beautiful little movement in it, 21 joules, and again that was utterly not working when I got it. I buy these really cheap movements just to practice on, but that one's very pretty. So there you go, unlike my gnarled old hands. Apologies for that. Right, okay. Gary, it was, I haven't been looking at the stream today, but sounds as though it's working okay. It was quite funny. Gary and I spent quite a lot of time fiddling about with various OBS settings and wondering whether the ride was producing HDMI compatible audio, and nothing would work. So I had to go off and have lunch, which won't surprise Mike. And then as I was finishing lunch, Gary texted me and said, well, I don't understand it. It's suddenly working. So I like to think, Gary, that what you and I were doing had something to do with it. Maybe it needed more than one restart. Right, very good. Well, with that, let me just have a quick look on the list in case anyone else has come up after Mike. No, so it's therefore round to you, Mike. And I wonder what you've been up to this week. Good news on GB3HV, by the way, but we can discuss that later. G0, Mike Juliet Whiskey to take it, with the Oscar 100 Net G4FKK standing by.
Okay, thank you, Martin. Hopefully getting out. I'm receiving myself, so let's hope so. Just trying to understand Noel's question. But yeah, been an interesting week. I've been somewhere, first time in a long time, so I had to go to a meeting in Germany, and flying there was interesting. There were no delays or anything like that. Paperwork was a pain in the neck because of the system didn't seem to work very well, but all went okay in the end. Anyway, fascinating those LDMOS devices, Ed, that they're photoelectric. I didn't know they were photoelectric. I've got lots of XRF 286s, and I got some from China which worked as well. So they're useful devices. Of course, most of them came off Spectrian pellets. And they were used extensively on 23 centimetres until QO-100 came apart, and then everyone wished they still had their pallets. But never mind. And Salo, I'm sorry to hear about the circumstances of the accident. Hope you do get well soon. It can be a bit disconcerting having an accident like that, I'm sure. So get well soon. And Leon, of course, a wonderful presentation as always on your monopulse. And I'm not quite sure what you called the other one, or what the other one is called, but I know what you mean. So that was good. And Martin, I think your picture was a lot sharper this time, so I don't know what you've done. Maybe you're using a Polycom or a different camera, but the watches looked really good as well. And yeah, and Benno all good as well. So it's sunny here on and off in the UK, but it's been cold, as Martin was saying. Right, let's go to some pictures of some stuff. So on the bench is the new version of the Amplifier controller. If you've got a good memory, the previous one was green, this one is now purple. And it's Mark II of a PCB. So yesterday was spent taking all the parts off the Mark I PCB and putting them on the Mark II PCB, well, most of the parts anyway. Recycling them rather than putting on new ones. And I'm pleased to say it works, so that's good. So I think that's just about ready. I noticed one or two things which I can improve easily. So that's good. Next to it is a 77's amplifier, which I've just put together this morning on an old board I had. I don't know if it's going to work yet because I need a driver for doing some testing, and that's when we come on to the exciting stuff, I guess. So on the Polycom, I don't know if you can see that. Maybe you can, maybe you can't. Yep, there it comes. Is a amplifier palette. That's one side of it. It's the same on the other side, which we've acquired surplus of late, and there's a lot of them about apparently. So Gareth and I have got some, and I think some of the others, and we've been looking at how we might modify these. So the shack's in a bit of a state, but let me just zoom in and show you what it is. Is that zoomed in enough? Yeah, let's go up a bit. So we've got 6 of these pallets times 2, which are 600 watt devices, and the 4 in the middle have screws connecting them to the heatsink, aluminium block that's water cooled, and the ones on the edges don't. The reason for that, I think, is the ones on the edges are soldered to a copper heat spreader, which is underneath, and I think these must be the peaking amplifiers, and the ones in the middle are probably the sort of the standard amplifiers, or the other way around, to deal with DVB-T. And there's an incredibly complicated system of underneath is how they're all fed by. So that's that board is all around the phasing and the combining, and they're driven by this thing here, which is a Doherty amplifier. And I don't know if it'll zoom in any more on that. There we go. Classic Doherty design apparently. Doherty design rather. I keep saying it wrong. But it's a broadband amplifier. So anyway, we've done a bit of testing, and I've been testing, oops, wrong direction, this pallet first, which is one of the, you can see the connector has been replaced by an N-type, and there's been something fed into it, and the original coax is disconnected. And for about half a watt in, I get about 100 watts of DVB-T with acceptable shoulders, 30 dB down or so. You can get lower down, but my driver is the limitation to this. So pretty good. And if you put in a bit more power, you can get 200 watts out of CW. But the interesting thing is the power that you get out in broadband, in wideband modes, DVB-T and S, looks higher on the bird through line than it does for CW mode, and I put that down to the peak reading nature of the bird versus the non-constant amplitude of the signal. So it's something to be aware of. But although the devices should be able to give 450 watts of FM or CW or SSB, they're broadband matched, and actually they'll only give about 200 watts, and they're very inefficient at doing that. So they're not, as they stand, SSB amplifiers, but they are wonderful DVB-T amplifiers, or DVB-S amplifiers. So that's what they are. So more work to be done on these to see how they work. And okay, yes, I know about the blue relays. I'm only going to use this device at low power, but what I'm concerned about, and I might bypass the blue relay, so let me just show you what was it Benno? Yeah, was talking about by selecting the other camera. So on this board, which was a cheap Chinese board, there were 2 blue relays. One of them's seen the soldering iron already, you can tell that. I don't think they're very reliable, and I might actually just bypass them altogether. That might be the best thing to do. that's a 30 watt 77 PA module. I want it to generate 2 watts or 3 watts. So I'm going to put attenuators after it to hopefully make it stable. So I might need to actually run more than 10 watts. So yeah, but not for very long. So thanks for the comment there. Right, okay. I think that's probably enough from me. I don't think there's anything else to show apart from maybe if I zoom out a bit. The shack's in a bit of chaos because I've been using this big amplifier here to power to do the DVB-T tests. And if I go back to the other camera again and move it around, you can see, oops, this amplifier is the one I've been using to drive it. This enormous thing I got from Gareth, thank you Gareth again, is a 25 watt OFDM amplifier with its own linear 28 volt supply that I was using to generate the 2 watts, putting it through a 10 dB attenuator. But it's a little bit heavy and bulky, so hence building the little one just for testing purposes. And that is my Portsdown stroke Langstone, which I was using to generate the DVB-T because it has a Pluto in it. So there we go. Right, okay. Let's go back to me, and I guess I pass it to you, Gary. So ZS6YI G0MJW.
Okay, Mike, let's just get this thing to lock. Righto, that's been a very, very interesting session today, I must say. Thank you to Leon. And yeah, fascinating, Leon. A lot of years of experience and knowledge on that. And it's certainly a very interesting job you had, that's for sure. It's funny, you know, normally if it's your hobby, it doesn't become your job. And if it does, it gets boring. But the white, why is no video? What's going on? Why it? Sorry. Any correlation? Why somebody's, what's going on? I see I've got no locked video on the streaming side. Let me just check on the other receiver. Yeah, it seems okay now. But yeah, never knew the UV thing has an effect on it, or the light, shall we say. And I'm just wondering if there is a correlation between the light and the UV. Yeah, it looks like when I transmit, I'm causing a slight bit of interference here. Every other station was fine on the streaming. Anyway, but thanks for those tips there, Ed. I wrote them down from gate to source, etc., and what you found, because I went through the very similar procedure just recently with old man Saro's amp. Benno, you can try using the Foxtrot 1 Echo Juliet Papa streaming software, and that will get your null packets and everything sorted for you. What I think you might have too much audio bitstream rate, so you can reduce that and that'll up the null packets a bit. But instead of fiddling, you try that stream and go to a virtual cam setup. I can send you the info and it's very easy to do. And then you get really good video quality on average. And so I finally converted Leon to go over to that. And since then he hasn't had station breakdowns in the sense that things freeze as much. Yeah, Martin, certainly it was a lot of help from your side to trying this, trying the next thing. In brief, guys, what I did was I kept on freezing using the mini tuner direct into the computer and then trying to stream it. I think for whatever reason I had a glitch from time to time, it would freeze. So I got the ride and I thought let's use that, and let's use the HDMI output with the audio, and see if I can't then just load that through a HDMI to USB converter and then stream that. It streamed the video beautifully, but there was no audio. In fact, the audio sounded like Donald Duck. It was completely crazy. It was like double the speed. Anyway, I have a nice USB 3 video capture, and it can also do HDMI 4K. So I used that, it didn't work. And then it has an outlet slot. So I plugged audio outlet, so I plugged a pair of headphones in, and I could hear beautiful audio in the headphones. So I was already contemplating taking that audio and feeding it into the computer separately. But all of a sudden I saw the bar graph coming up on the feed. That's on the YouTube stream. And I thought, oh, that sounds good. So I quickly went on, and lo and behold, there was audio. So I thought maybe I'm just loading that plug. And so then I did another test while Martin was having a wonderful meal. Eats too much, doesn't he? He's lucky. And I unplugged the headphones, still worked. And I switched the whole contraption off, started up. It's been working ever since. So I don't know what the darn reason is. Perhaps the computer finally found the proper driver, perhaps. Or as Martin said, maybe we needed a complete reset with the changes we did. Although, Martin, the changes we did is not too dissimilar to what I had originally. In fact, I went to the original settings again because I upped the video bitrate from 1,000 something to 4,500 because the YouTube stream was complaining it needed more bitrate. So I did that, and I also upped the audio bitrate a bit. I wish we had pipes like we have on YouTube over the satellite for sure. And it's been working ever since quite nicely. So I'm happy about that. Yeah, the YouTube stream, maybe I can put it on the screen a bit later. I'll have to copy it and see if I can paste it on. And then maybe next weekend I must find a way to quickly put it onto the actual camera here, and then guys like you, Mike, can perhaps just go and click on that and see what the YouTube stream works out like. But we can always email it to you. You can always go back and check it, by the way. So that's one good thing. It stays in memory. It's stored. Right, so that was that program. And then, yeah, Mike, again, you know, I managed to look at some of the program on Thursday on the BATC, and I saw this amplifier you were working with, is it the Dolphin? But yeah, very interesting. That thing can pack a punch if you get them all singing in the same sort of phase and tune. That'll be quite an amp and a half, that's for sure. And yeah, Ed, you know, you remind me with that cartoon of exactly what we want to do with the 4.2 meter dish I've got. I want to build everything in a box similar to what Tom did, and put it right up, this DATV thing, put it right up at that at the antenna to prevent any losses, and just have a few meters going to the feed. That is the intention, in fact. It's been for a long time, but I've been battling to get mesh. Just can't get mesh in South Africa of the port, you know, diameter that I need, the aperture. Over the years, wind damaged some of the panels on my current dish, the 4.2 meter, and you know, it wasn't so bad. I could have panel beated it out nicely and got it smooth, but I thought I'll just put new mesh in. So I took a piece of mesh out and then cut up samples so that I could send them to various people to perhaps source. Not one guy can get me any, not one metal supplier can get me aluminium mesh like that. So I've cut up a panel for nothing. But I'll have to make a different arrangement. I was even thinking of making it a solid dish and get done. I have the aluminium. It's thin, 1 millimeter, about 0.8 millimeter. It's not very thick. And maybe just take all the petals out and do that on a solid thing, except it will increase the wind loading tremendously. However, I have a nice sturdy construction and something like 5 cubic meters of concrete at the bottom, so it should hold it. But you know, if I can get the mesh, that'll be first prize. So there we go. Right, with that, I pass it for one more round. How's our time? It's a little over 4, and then we'll wrap up the net. Back to you, Leon. ZS1 Mike to take it from ZS6 Yankee India in the group.
Oh, sorry. I forgot I switched off the amplifier since my last transmission, because it was quite a row of people, and I just thought I'll just let it rest a bit. Okay, yes, very interesting. Let me see. Okay, yeah, the LDMOS story, Ed, very, very interesting. Yeah, the testing it with the ohmmeter, that's what I always do. I never knew they were photosensitive, like OC71s, hey Martin? Scratch of the paint. So that's, yeah, and maybe that'll give an indication of the gain. I don't know. I'll have to try a couple, but yes, that's a very interesting thing. Okay, Benno, yes, you with your repeater upgrade. Oh yeah, I'm still gathering bits and pieces for my DATV repeater. I'm still not sure what configuration I'm going to use. It'll be digital only, of course, but will I make it like a bent pipe repeater like the satellite, or am I going to demodulate, or whatever? Having a bent pipe is the easiest, with perhaps just a narrow little section, so that it has to lock properly before it will transmit, so you don't get other interference also going through the repeater. I don't know, but we're thinking about it and gathering various little bits and pieces. I got some nice old UHF repeaters the other day with nice filters, which obviously, because I want to go 70 centimeters in and maybe C-band out, because you can still get C-band LNBs, you see, because that'll work very nicely onto a mini tuner, so the receiving end is then sorted. So if I can go up 70 centimeters, which the Pluto will do, and come back C-band, yeah, that's what I'm thinking. But if not C-band, S-band is so polluted. I think I'm trying to receive anything terrestrial on S-band is, oh no, the cell phone companies have taken over. Even our telemetry at work is having a major battle. I think of the whole band that we had, 2.2 to 2.4 gigahertz was clean in South Africa. It was reserved for telemetry. It's all been sold out from underneath us. There's a slot of maybe 1.5 megs wide here at 2235 or somewhere there, where we're not getting much noise. But for the rest, it's just spikes. It's just all this new. Oh, it's terrible. Anyway, okay. So I don't want to receive S-band on my repeater. The receiving there is a waste of time. How the moonbound guys still do it, I don't know. Well, at least they're looking away from the Earth. Okay, Martin, yes, it's not 55 dB the gain on my antenna, it's 35. Hey, we put it in Scottish for you? 35. Charge the battery pack. Oh yes, my camera's unplugged because I had the whole business out. My camera's going to die shortly. So it's 35 dB and the 21 joules movement, lovely. Hey, oh man. I know towards the end of watches, mechanical watches, they really skimmed on the joules. Definitely not 21 anymore. Mike, your amp controller and amplifiers and stuff's always amazing and always so neat and beautiful. So what happened to Henry? ZS6 Mike Charlie, is he not coming up on anymore or what? I don't know. Ed, over to you. Papa Yellow 2, Romeo November for the group. ZS1 Mike saying cheerio 73s, unless somebody calls me back. So take it, Ed.
Thanks, Leon. Please don't go away. I need to show you something. Very nice presenting. Thanks, Gary, for explaining your new streaming system. It's working great, I tell you. That saved me during Leon presentation and during Mike's presentation, because I lost signal from Mike several times. Yeah, guys, I have only 7 degrees elevation here. My reception is very critical, and I will really suggest to you all to change the FEC from 3/4 to 2/3. So this way the lower signals are going to be more stable for me, or for the others that don't have a very strong reception from the DATV signals. Forgot to mention about Saro. Hey Saro, as you can realize, everybody is missing you, so hopefully you can get back to the DATV Net soon. My best wishes, fast recover, and yeah, we all missing you, and other guys from India as well. I really missing you know, other guys. I will not decline the names, but all of them. I hope those guys come back to the DATV Net, because they all helped and they all started the DATV Net, and it would be nice to get them back. Hey Beno, sorry, cannot help you with the repeater, but that would be interesting if you prepare some you know, block diagram or something to show to us here. We are thinking, me and another guy here is thinking about something about to do a terrestrial DATV repeater, but we never had one here, so maybe we can learn from you. Great job with your clocks and watches. I see my transmission is bouncing. I don't know why, but that's hopefully it's back. Mike, wow, huge amplifier. I just wondering, of all those boards you said each one is capable of 600 watts on 70 centimeters. I'm wondering if they are disposed like that, because probably commercially use it, then they put it all of them in a combiner and generates about what, 3 kilowatts, maybe 2 kilowatts. It's huge. It's impressive, Mike. We had a viewer here from Brazil, which is Gustavo, Papa Radio 80 Kilo Whiskey, and he also works with you know, maritime communications, and he just watched to Leon presentation, and he sent me some pictures on how, you know, the Conscan works for maritime VSAT and maritime TV reception. Those are the Conscan, Leon, that they use today on the boats, on the ships. And that's very quite interesting. He sent me another one, yeah, that one. Yeah, that's that type of antenna for VSAT and TV reception. That what I would like to show you, Leon, and for the others here on the net. So thank you very much, Gustavo, Papa Radio 8 Kilo Whiskey, for sharing those pictures. Very nice. Okay, that completes my part here. If I can switch back to my local camera here, and I pass to you, Beno, Papa Alpha 3 Fox Bravo X-ray 73 to everyone. Have a great week. Ciao, ciao. Until next.
Yeah. Great stuff. First, what I want to make some comments on. First of all, I know the F1 Echo Juliet Papa free stream coder. I use it quite often. Actually, I was a little bit astonished that you were able to set the PIDs there, but it didn't accept it in the older versions of the Pluto, but it accepts it in the current version. That's the way how I managed to get it working. But like I said, using that piece of software to get it organized, I also use directly out of OBS with the hardware encoder in my computer, and then I get this kind of strange null packets. But I will try to figure out how this works. For the streaming part, yeah, I don't know why you guys want to focus on the YouTube. I neglected YouTube last year when I started to stream from our local repeater, because YouTube was a kind of a bitch, asking too much, and you need 4 megabytes of data rate and things like that. You cannot do any sensitive stuff, or you will lose your image or your audio. A lot of issues, and the main thing is it's recording everything. That may be an upgrade, but for a 24-hour stream, I don't like a recording. I just want real-time transport, real-time vision, and I don't want to record it because otherwise we get all kind of issues with copyright and other things. You have to pay for someone's view, and then, well, I don't want to go into that discussion, so I don't want recording, and that's something YouTube kept on doing. And then the last part is every time you break up the transmission and you start it again, you get a different address. Try that to make that automatic, or to automate it, or to send it to the people to be able to be found. Obviously, you can do a search, but hey, that's why I left YouTube and went to Twitch, which is 24 hours, always the same, and never recorded. If you don't want it, it's the recording on my Twitch is just switched off, so there's no recording, and everything is what's gone is gone, and that's the way I like it on this part. Well, that's about streaming. You're welcome to have a discussion about the repeaters. They have a big knowledge on repeaters in England, but I tend, Leon and I tend to move everything to audio and video, and because I also want to use a quad to have multiple inputs, and multiple outputs, and switch to all kind of calls, because you need if nobody's using it, you need an image, a beacon, or whatever. So you need all kind of switching, and therefore the best idea is, in my opinion, is to move it to get it to video. If it's HDMI or if it's composite, it's your decision, and then switch it the way you want, and then move it back onto a carrier to whatever mode you want it, and then you have it versatile. And the main advantage is you can also transport it then directly to the internet if it's capable, because a lot of people, like you said, cannot receive the input but can transmit on 70 centimeters, and then you can at least compare if you have been received over a certain distance. So that was my idea, and the problem now is that digital, obviously, as we know, takes up to 2-3 seconds. Twitch is about 3 seconds. Moving back and front, copying via Pluto is actually more. And that's the main reason why a lot of old-timers want analog TV next to it, and therefore I need to switch everything front and back, analog to analog and digital to digital, like I said, and that's real, like I said, Martin, pain in the ass, but we'll manage and we'll get it, we'll prevail, I should say, and but it just takes a lot of time, and well, like I said before, I'm not a programmer. I just try, I copy, and I try again, and it takes hours to figure out what works for me and what doesn't work. And on the fly, I learn how to program a little bit. Okay, well, that's all for now. I will make some kind of presentation. I have some big improvements after last week, and I made, well, I can obviously can make some video of that. Well, that's all for now. Greetings to the group. Hope to be back next week. I'm not completely sure because I have an appointment then, but let's see what happens. And if I'm available, I will be on the net next week. At least I try to switch my stream always onto the right channel, and but it's 24 hours in the air, so the minute the net ends, it goes back to the 9-pip and sends all kind of information from the satellite onto Twitch from this QO-100. Okay, greetings. Microphone on to Martin from Papa Alpha 3 Foxtrot Bravo X-Ray.
Yep, fine, Benno. PA3FBX, G4FKK. Let's turn that down. And yes, well, hopefully you're copying okay, Ed. I think I'm running 2/3, 2/3 FEC, so I usually do. But yeah, all very interesting. And yeah, Mike, that amplifier looks fantastic. I must find out where you get those from. Although, to be honest, I've got my Dolphin, and I certainly don't need 12 of those pallets. But it is a beautiful looking thing. It's a bit like the Dolphin. I took all those boards out of the Dolphin that you did, Mike, and but I've kept them all carefully stored because they're just too nice not to use probably one day for something. Who knows what? The board's looking good. Your new boards, and fine business on the meeting in Germany. Yeah, I wondered what flying around Europe would be like at the moment. And yeah, Gary, it was interesting. The streaming thing's interesting, by the way. I'm just noticing Noel and Mike discussing things. If I quickly nip over to the unsteady cam, if you are still watching, Noel, I've got one of those Chinese encoder boxes, so I thought I know, that sounds good. I'll try that out. Unfortunately, I've plugged it in, and I can't remember what IP number I gave it, or whether it's DHCP, and it's not showing up on my BT router. So I need to find out where that thinks it's talking to. But well, yes, so I could stream it, Noel, if only I knew how to. I've never used that encoder box for streaming anything. I can't remember what I used it for now. It was an early attempt to get H.265 onto the satellite, but yeah, I know what the default is. Unfortunately, that's not on my network, so I will have changed it at some point, Mike, to go on my local area network. But I can't remember whether I changed it with a fixed IP or DHCP, or maybe it's forgotten what I did and it's gone back to the default IP. Anyway, I'll have a play with that later. Leon, sorry, I misheard that. I thought 55 dB. That's very good. So 35 dB sounds more manageable. And 3 degrees. So presumably my 1.1 meter dish will have a wider beam, but I find that hard enough to point in the right place. And the wind finds it a lot easier to shift it off the focus than I do getting it back on again. And oh yeah, you've got to have a non-standard network, Mike. It's standard in this house. What was the other thing? Oh yeah, YouTube versus Twitch. I've never even looked at Twitch, Benno, but it sounds quite good. YouTube is always, it's like all these things, isn't it? I recently ventured back onto Facebook because someone told me that they'd left me a message there. And Facebook was really good when it first started, dead simple and easy to use, no huge security issues. YouTube was the same, but it all gets overcomplicated and overpacked with adverts and things. I don't know if Twitch has adverts. YouTube's quite good for me at the moment because my son pays something to them, and as a result it means I don't get adverts on YouTube anymore, which is a huge relief. That's a good salutary warning to anyone who wants to make the BBC commercial. Adverts. Right, okay. Well, if you are on next week, Benno, looking forward to the presentation you just promised us, we all heard. And it would be nice to see Henry. I think Henry said he might come on next week, so that'd be good to see you again, Henry. I saw you off and on during the week, so I've seen the signal getting steadily better. Or their adverts on YouTube. There are if you don't pay them money, Mike. So unless you're some special case, they're taking money off you. Right, okay. I will say 73 for now. Thanks, Gary, for running the net. And I shall look forward to seeing you all again next week, or some of you. And as everyone's saying, Saro, do get better soon. We do want to see you back on the satellite. G0MJW to take it. G4FKK saying cheerio, and over to you.
Okay, with another dB because it's a bit difficult to change my FEC rate on the fly. Sorry about that, Ed. I didn't realise that you were quite that close to the limit. I thought you had a bigger dish, but noted it's only 7 degrees. That's still quite high compared to a lot of places, I suppose, right on the edge of coverage. All good, all really interesting. I don't have very much to add. Those pallets, the whole thing is a 1.25 kilowatt amplifier, which are then combined into TV broadcast stations. So 1.25 kilowatts from 12 pallets. So each one is typically running about 100 watts, and they're designed to do that 24/7. So it's all water cooled and everything else, and the power supplies are enormous and 3-phase, and I'm not quite sure if we can make use of them. We might be able to. I can show you a picture of them perhaps if I swing the camera around. But let me just do that actually. So firstly, that's the driver's stage, which I was showing you before. Now the question is, which camera are we on? We're on the wrong one, but I don't know if I'll be able to see it with that one, so let me just swap it over. Camera number 1. Oop, there we go. Swing around this direction, move up past Hacker, zoom in. Yeah, you can just about see the power supply there. It's a little bit obscured by the Hacker. It's 19-inch rack sized, and there are 3 units, 50 volts each, and they're run off a 3-phase supply, but each one is 240 volts. The amplifier was 1.2 kilowatts, but it's only 25% efficient. So based on that, I would say each one of those power supplies must be at least probably 2 kilowatts, just to be on the safe side. So they're pretty chunky things. And they were also sitting on the water-cooled base, which is a wonderful thing to behold. But unfortunately, in the useless bracket with respect to what we would do with amateur radio. Okay, 7th everyone. Hopefully catch you next week. Really good to see everybody and catch up. And all okay. So with that, round to you, Gary. ZS6YI G0MJW.
Okay, Mike, let me just also add a bit of juice to the story. And just for Ed's purposes there, I don't like to go that high, but no problem. Right, with that, I'm going to wrap up the net now and wish everyone a happy week. And yeah, Martin, you asked what happened to the dog. Well, the dog went silent key, but it could have been worse. It landed between the wheels. Can you imagine, on this motorbike? It just the timing was just right. Another half a kilometer an hour, and it would have gone behind the thing. But then again, conversely, half a kilometer an hour slower, and they could have hit it head on, and that would have been disastrous for the passenger and, of course, for Sarah. Anyway, all's good that ends well, and thank goodness it did. Even though Sarah was quite damaged, he says no, he's feeling fine. So we did a quick WhatsApp telephone call, video call. My gums, he's far from okay. You should see the bandages. The guy's really messed up. So Sarah, yeah, it's been brave, but recover quickly. And yeah, indeed, very interesting from you again, Mike. And also, just reading the quick comments between you and Noel, I think it was. Yeah, Noel. Yeah, seems interesting, Noel. I'd like to touch sides with you a bit more and see. I've got one of those Chinese things, in fact. Now, I gave it away to somebody last week because he didn't have an NVIDIA card, and then he eventually got one, so he returned it. So maybe it's good, and I can use that. But the ride's working flawlessly now. It hasn't given one drop of problems. A very nice receiver, actually. So all's good. It's streaming nicely on YouTube. And Benno, all noted. I understand what you mean. It's nice to have a copy of it because we're putting them into an index. Ed's got the site. I think it came from Roberta. I'm not sure whose site, but I'm using someone else's site. I do go on my own page and then YouTube things, but it's fine the way it works for Worldwide Net. So they're all together. If you want to go and see a program that's happened before, an interesting thing like from Leon, you can quickly go back and scan it, and there you have it on tap. So it's not running 24 hours, of course. Yeah, there are adverts on YouTube. It's rather sickening at times. Okay, with that, I'm going to throw the ball in the air. Wish everyone a very happy week. Hope to see you guys next week. And take care. And don't ride motorcycles too quickly at night. This is ZS6YI now closing the net and wishing everyone a happy week. 7-3 all, and thanks for coming on.
Yeah, I just want to say to Ed, tell Gustavo thank you very much. That's very interesting. I was always wondering, how do they, with the satellite communications and stuff on the ships, how do they keep track of the satellites? So they also use Conscan. It's the easiest way, and it's foolproof. Once you've got it, it'll stay on it. So yeah, very, very interesting. Thanks for that one, Ed and Gustavo. ZS1 Mike is now off and clear. Bye-bye.
Thanks, Leo. I may forward the images to Gary, and he will forward to you. 73 to all. Bye bye.